two planar concentric rings of metal wire. Two planar concentric rings of metal wire means there are two rings which are lying in the same plane and having common center. Having radii r1 and r2, their radii are different such that a coil of radius r1 is greater than another coil of radius r2, and they are placed in air. Both the coils, they are placed in what? Air. The current I is flowing through the coil of larger radius here. Outer coil of radius r1 and it is larger, and let I is the current flowing through it. The mutual inductance between the coil is given by, so we want to know what is the mutual inductance between these two coils, mutual inductance between these two coils. Now we know that since this outer coil of radius r1 is carrying current, that current carrying coil produces magnetic field at its center, and magnetic field, as far as this magnetic field is concerned, magnetic field at the center of larger coil, magnetic field at the center of larger coil. What is magnetic field at the center of larger coil? It is given by a formula B equal to mu 0 I divided by 2r1, mu 0 I divided by 2r1. Now the magnetic flux linked with smaller coil, because this magnetic field is associated with smaller coil also. So that's why we can say magnetic flux associated with smaller coil, magnetic flux associated with smaller coil of radius what? R2, smaller coil of radius R2 is flux phi is equal to magnetic field B multiplied by area of cross section of second smaller coil. So that is equal to B is what? Because same magnetic field is passing through a coil of smaller radius. So it is mu 0 into I divided by 2r1. But the area of cross section of smaller coil, it is pi r2 square. It is what? Pi r2 square. So flux associated with smaller coil, it is mu 0 pi I into r2 square divided by 2r1. Mu 0 pi I into r2 square divided by 2r1. Now we want to find out the mutual inductance of two coils. Mutual inductance. Now as far as mutual inductance is concerned, mutual inductance is defined as rate of change of magnetic flux associated with one coil, say associated with second coil, to that of rate of change of current flowing through the another coil, say the larger coil. Or we can say M is equal to, here time get cancelled and we are having phi divided by what? Current I. Phi divided by current I. But what is that? Phi is mu 0 pi r2 square into that current I divided by 2r1, and here that current I. So I get cancelled with I, and the coefficient of mutual inductance, it is mu 0 pi r2 square divided by 2r1. Mu 0 pi r2 square divided by 2r1. Mu 0 pi r2 square divided by 2r1. So if you look at the option B, mu 0 pi r2 square divided by 2r1. So B is the correct option for this question. B is the correct option.